how to build a multi-agent role-playing game master with Strands Agent. Quick question right before starting. Do you know, raise your hand if you know what is a role-playing tabletop game?
Who's played it?
Okay.
Few people don't, so if you want to make a
most
introduction.
Most people know, that's cool. Sometimes we play this presentation in different countries, and depending on cultures, maybe sometimes people don't know.
See, some people didn't raise their hands, so if you want to make a brief.
Tabletop role-playing game is, you might have heard of Dungeons and Dragons or games like this. So basically, this is a this is an open world with a universe that already exists, that has a playbook, like a rule book, that you can read. It's like 400, I think, pages long. And basically, you can play in this universe where you can play, like, for example, elves, orcs,
Druids.
Dwarves, and have your own characters, and you can play a campaign. And for example, you have what we call a dungeon master. So the role of the dungeon master or the game master is to build a campaign to embark the players into a story in this universe. And the idea of this project was because I am myself a Dungeons and Dragons player, and I sometimes have troubles finding game masters because it's really hard to be a game master, actually. You need to know all of the rules of the game. You need to know a lot of things to be able to drive your players into a campaign. And I was thinking that maybe artificial intelligence could be a cool tool to help game masters in assisting them. And we'll see today how we can build a multi-agentic workflow for this. So first, I will introduce you the concept of agents. At the very beginning of when generative AI became very public, I don't know if you remember, because I remember the announcement was made during reInvent. It was 3 years ago for, for the well-known ChatGPT, but generative AI existed before that, but it became well-known by the public by this day because it was a tool that suddenly everybody could use and see the power of it. So you could chat with those LLMs. You can have a conversation with them. But this is about it. When you chat with an LLM, you can have a conversation. This is very powerful, but what you'd want is also this LLM to be able to perform actions for you. And this is where agents come into play. Agents have agency. That's what we call them, agents. They're able to make actions for you. And the way they do those actions is because they have access to tools. Tools can be a lot of different things. They can be APIs, they can be functions, they can be databases. They can also be other agents that also themselves have access to other tools. So you can see how this can build up pretty quickly. Usually there's no standard really, but at the moment, when you have multiple agents working together, you usually have one orchestrator that has access to multiple agents that each are specialized and experts into a certain task or a certain field. One example that I like to give sometimes is when you want, for example, a coach, a studying coach for a student. You'll have the coach that might be connected to a team of different agents that are all experts in different fields, in math, in physics, in history, in geographics. And so you have all of your different agents that are all of the teachers, for example. And whenever your student has a question to the coach, or maybe is asking for a set of exercises, or maybe questions about something, then the orchestrator redirects the questions to the right expert, to the right agent, to be able to perform, to answer the query. So, yes, to connect those tools, to connect the tools with the agent, we have what we call the protocol MCP. So MCP stands for Model Context Protocol. You might have heard of it because it's been doing this boom for this entire year. So basically, this protocol standardizes the way your agents can discover tools. Basically, it's like REST for AI agents. If you've tried to build agents before with tools before the MCP protocol, maybe you remember, but it was pretty complex. You had to maintain the way you'd connect to the tool, for example, a function. There was no standardized way of doing it, so I mean, you were the only one who was maintaining this whole workflow, and in the same time, you weren't able, unless you were talking to that person, but you weren't able to connect to a tool that someone else would have built. And the power of MCP is that now, if someone builds a tool and puts it on a server, on a certain endpoint, and give it to you, then you, on the other side, with your agent, is able to connect to that tool. This is making things very powerful because now a lot of people are creating a lot of tools, and with your agent, you are capable of using their tools. And also, there is another protocol that has been very famous also for this year. It's A2A, which stands for agent to agent. And this protocol standardizes the way agent connects to other agents. So, two very different things. One protocol is to connect to tools, and the other protocol is to connect to agents. Why are those protocols different? Because the way they communicate is different. Between agents, you need to be able to build a conversation. They both have a thought process. They both have planning. And so they need to be able to have this conversation. Meanwhile, for a tool, you don't necessarily need to talk with it. Actually, they don't have this thought process. The tools are just like functions or API calls or databases. So they're just going to give you an information. They're going to perform an action for you, but that's pretty much it. So So basically, to sum it up, MCP versus A2A. MCP is to communicate between tools, agents and tools, and A2A is for the communication between agents. So today, we are going to work on this little project. Actually, Olivier is going to build it live in front of you, which is really cool to see.
Part of it.
Yeah, a part of it. So when I was building my project for my Dungeon Master AI assistant, I wanted it to be able to do a lot of things. Actually, if you start thinking about it, the task is pretty tremendous if you want an AI assistant for game masters. So the first thing I did is that I had the orchestrator. So that's the AI game master that is talking to me, but as I said before, it has access to other tools and other agents that are each specialized into their different tasks. So this agent that I'm talking to has access to another agent that will be the character manager, for example. So the character manager is able to create characters on the fly for you. It has access to a database of characters, so it can also get characters for you from the campaign. And it also has access to, it just has access to the database, right?
It has tools to access the database, yeah.
Yeah. And a second agent is the rule agent. So the rule agent has access to the full book of rules of Dungeons and Dragons. So it basically is a RAG. So to make sure that whenever I want to do something in the game, then my orchestrator is actually able to ask the rule agent, is this possible? Or in the mechanics of the game, is this logic? And finally, there is an MCP server that we have where we run a tool. So it's a very simple tool I will show you. I just needed my agent to be able to roll dice for me. You know, like a dungeon master usually takes decisions as he rolls dice for you, like D20 or other types of dice also. And so I put this function into a MCP server and use the MCP protocol to connect it to my agent. Yeah, so that's what we'll build.
Yeah, it's good.
Okay, at the end of it, we'll show you a more complex version of that demo. But just to show you,
To build it,
of course. We are going to build this in the time frame of this session, thanks to an SDK. So Strands Agents is a software developer kit that for Python, but we'll announce maybe.
Stay tuned this week.
Yes, for building agents in just a few lines of code. And you'll see that this is literally just a few lines of code, which is really cool. If you've built agents and multi-agents workflows before, you'll see how much simpler this is now with Strands. And it supports MCP and A2A, which is great, because we've been waiting for this for a while. So this is what we use at AWS internally, Strands Agents. This is...
Yeah, if you've been using like Amazon Q, that's using like Strands Agents in the back.
Exactly.
That's when we open sourced it like a few months ago, but we've been using it on Amazon Q for quite some time now.
Yeah, there's a lot of internal tools that actually have been built with Strands internally. So this also gives you an idea of how robust this can be, because we run on huge projects with multiple agents.
And it's very easy to install.
Yeah, so the first thing you need to do is to install this library, pip install Strands Agents, and then you're good to go. Let's do this demo.
Right. Demo time? Ooh, nice. Are you ready? Yeah, okay, if you are ready there, I'm going to do it for you. All right, so here I have my, so it's Kiro, it's like my IDE, and basically I have nothing. I have like a app.py, an empty file, and a requirement.txt where I have my Strands Agents and Strands Agent tools. We're going to see later what it is used for. But I wanted to like start with like a blank project so you can see from start how it works. So first things I'm going to do is I'm going to import Strands. Okay? So I import the agent class. So I'm going to create an agent object, and then I'm going to call it. Let's say, good morning, Vegas. Okay, let's do it. So I have 3 lines of code. Let's see if I execute them. So now what's happening now is like it's replying, good morning, I'm actually Claude, an assistant, blah, blah, blah. Not in Vegas. Okay, you're an AI, you're not in Vegas. But what you can see here is like in 3 lines of code, I've created an agent and called an LLM of my agent. So now you may wonder, so what kind of LLM is called in the background? So you can actually print that out. I can check my model here, and if I call it again, you'll see that by default, Strands used Amazon Bedrock, and here by default is the Claude Sonnet for LLM. But we can change that actually. If I import the Bedrock model class, I can create a new object, Bedrock model, where I can specify any Bedrock model you can find on Amazon Bedrock. If I do that, I'm just going to take my agent. So as a model, instead of using the default one, you can use, please, the Bedrock model I just created. So now if I execute it again, you can see that now it's using Amazon Nova Premier. And you can play with all the configuration. If I want to change the temperature, for example, I want to select 0.7, whatever. And you can change that, and you see that the temperature is changed for my call. And so if you look at the Strands documentation here, strandsagent.com in the user guide, you have the model providers here. And actually, you have access to a lot of models. So we saw that there's Amazon Bedrock. You have Entropic. So if you have like an Entropic API key, you can use it. So Strands is model agnostic and even provider agnostic. You have like a Gemini, Llama, you have a Mistral. We are French, so let's promote that. You have an API key for Mistral. You can use it directly here. You can use basically everything you want. You can even use like Ollama here. You say you have a provider for Ollama. Do you know Ollama? If you don't know Ollama, basically it's a tool that allows you to download a lot of models. If you go on the models here, you have literally a lot of models. And what it allows you is it allows you to like download these models. They can go from like a few megabytes to like a lot of gigabytes, and to run them locally. And it gives you access to like an endpoint, like an API endpoint, so you can call these models. So you can even use that. For example, if I import like the Ollama class instead, and I say, okay, I'm just gonna create like an Ollama object. I need to give it the host. So here I have Ollama running on this here. So it's running locally on my computer, and then you specify the model ID. So in Ollama, to run a model, if I do that, it's going to download the model I'm running on my computer. So I have a bunch already installed. These are all the ones I have installed. You can see they can go from a few megabytes to a lot of gigabytes and even like way bigger than that. So let me take like the Llama 3.2, for example, here. Oops. Here you go. And here I'm going to tell him, OK, use the Ollama model I just created here. So if I run my code again, you can see that now it's using Llama 3.2. It's taking a bit longer because it's running on my computer, so there's no cloud involved there. And it's still replying to me. So now I'm using like a model locally on my computer. So OK, cool. Yeah, that's cool.
But it's not yet an agent.
It's not yet. It's an agent, but it's just running the LLM.
Yeah, it's an instance of a class agent, but now what's interesting is that you can add tools to it.
Yes, because the good thing with LLM is that they know a lot of things. They've been trained on like huge amount of data, so you can ask them pretty much everything, and they will have an answer. But sometimes you have like very simple questions, like if I ask, "What time is it?" Very simple, right? But if I ask that to my agent, it's going to reply to me. We don't need that anymore. OK, I don't have access to the real-time information, so check your device, check your clock, thank you. Ask an assistant, search on your web browser, or like look at your watch. Thank you very much. So a very simple question, but LLMs can't do that. And that's where agents are actually useful. So you can give them access to tools, and when they don't have the answer, they will check if they have tools that can help them answer this question. And the good thing is that Strands comes with a package of tools. So if you go on the documentation again, you have these tools menu here. You have a community tools package. So that's the, you don't even remember, that's the other package I had in my requirements.txt. And if you scroll down here, you have access to a lot of tools. Some to manage memory, to read and write files, to do cron tasks, use computer, it's going to move your mouse for you, doing HTTP requests, read images, generate images, calculation. There's one called current time here. So for example, we can use this one to answer a question. So if I do, OK, from Strands tools, I want to import current time. So now I've imported the current time, and all I have to do is to tell my agents, OK, you have access to all these tools. So I put them in an array. So right now it's only current time. And if I ask again, what time is it, you will see that it's going to call the tool. So it's going to call the tool current time, and then it's going to reply to me, it's 9. OK, in Las Vegas, let's be precise, you know. It's not 9 p.m. So I ask him again, he's calling the current time tool, and he's giving me the time. So now you can see that we enhanced our LLM with tools thanks to the agent. And you can do things pretty cool, like you have like file write, you can generate code. I don't know if you use like a code assistant like Amazon Q, but basically you can recreate like a very, very small like version of it. So for example, I have my agent, and I gave access to like this tool, file write, and Python REPL. Python REPL is a tool that gives you the possibility to execute Python code. So now I can do something pretty cool. I can say, OK, let's write some code. Like write a function in a file called fib.py that generates the first XE of Fibonacci. Okay, and then execute it. So I'm just asking that to my agent, and if I execute it, what is happening is that it's going to write the code so that LLMs know how to write code. That's okay. Then it says, okay, I need to write the file because you asked me. So I have this tool, write file. So for some of the tools, like write file, for example, is going to perform actions on your computer. There's a safeguard where it's asking you, is it okay for me to write a file? You can bypass that because in the CI/CD you don't want that. So you have like an environmental variable that can allow you to bypass these questions. So I say yes. So now you can see that I have this fib.py file that has been written, which is, I trust it like the Fibonacci function. And then again, the Python REPL one is going to execute code. So it's asking you as a safeguard, are you sure you want me to execute code? And then it's going to execute the file with the Python you just created. So you can see that now, with just like a few lines of code, give it access to like a few tools, it can create files, execute Python code, and it's actually pretty cool, right? Yes, amazing. All right, so, but we're not here to like rewrite Amazon Q, we're here to write a game master. So when I write a game master, I want access to other tools. Like for example, Tiffany mentioned it, we want a tool to roll dice. So actually, if you ask your LLM to roll a dice, it's going to answer to you because it's been trained on data that roll dice, but it's not like an actual random. So we want to have a tool that roll dice. And I don't know why the Strands team didn't think that having a roll dicing tool was generic enough to add it in the toolbox. So, but I can actually write a function to roll dice with a number of faces. Or I can write it, I can ask an LLM actually, write the function that it's 13.5, come on, I'm going to write the code. Roll a dice with a number of faces given as a string, manage errors. Okay, I'm going to run me a function, because that's not the point of this talk. Accept, okay, please indent it, nice. So here I have some code, okay, and wouldn't it be nice to just say, okay, I want my function to become a tool. That'd be cool, right? Well, it's not that easy, unfortunately, but it's not that much complicated. I just have to import this tool here from Strands, and then add a decorator on my function. And just by doing that, my function here, roll dice, is becoming a tool. So now if I ask it, okay, roll a dice of 6, and I execute it, here, it's going to call my tool, roll dice, that I just wrote, and then, roll 2 on a dice of 6. But I can also ask, like, roll a 3d20, which means 3 dice of 20 faces. And when I'm doing that, it's going to call 3 times my roll dice tool, and then give me the result, and even the total, even though it didn't ask for it, but bonus. But you can see that he called my roll dice 3 times. Pretty cool, right? I just wrote a function, it became a tool. Now, as Tiffany mentioned, there's two use cases where I don't want my actual tool to be written here. There's one use case where maybe someone else, somewhere, wrote a tool that is already doing that and put it behind an MCP server. So I want to be able to use this MCP server. Or nobody did that, and I'm like, oh, I'm a nice guy, so I'm going to put this tool behind an MCP server so anyone else can use it, right? So let's see how we can do that. I'm going to create a new file, MCP dice, okay? And so the goal is to take my roll dice here. Okay, remove that. So my agent doesn't do much, but it has access to an MCP server here that is going to be the one that has my tool, right? So to do that, I'm going to fast MCP. So fast MCP is not part of Strands. Strands is here to call MCP servers, but Strands is not meant to create MCP servers. So fast MCP is a well-known library that allows you to do a lot of things with MCPs, including creating servers. So I'm going to create a server here. I'm going to give it a name. It's going like a D&D dice roll service. Okay, you don't have to put all this information, but I'm going to say, okay, you run on my localhost, and I want you to run on port 8081, okay? Okay, so I've done that, and then I'm going to run my MCP server. So I'm going to say, OK, I want you to run. And MCP servers, there's like 3 ways of running them. Either it's like on stdio, when you run them locally. If you've done that with Amazon Q, for example, you can put like npx or whatever, how you want to run them. Or SSE, which is like server with pushing messages. Or what I prefer is like streamable HTTP. So it's like an HTTP stream. So I'm going to specify the transport. I'm going to say, OK, I want a streamable HTTP. Let's do it. OK, so now I have my server. It's running. All I need to do is to say, OK, I want this function to be a tool. So it works a bit like in Strands. FastMCP is like you put your server and a tool decorator. So by doing that, I have a MCP server normally that's running. All right. Or not. What did I do wrong? Oh, it run. My bad. Wrong function. So here you go. On the bottom left here, I have my MCP server running on my local host on the port 8081. So now what I want to do, I want my game master agent to be able to call this MCP server. So I'm going to import the MCP client class. And because I'm using like streamable HTTP, also the streamable HTTP function. And so I'm going to say, OK, my dice MCP. I'm going to create an MCP client. I'm giving the function streamable HTTP. And I only need to give it the URL. So I'm going to take the endpoint here. What do you want? You want paste? OK. 8081. OK, so now I have access to like a client MCP to my MCP server. And I'm going to say, OK, by just doing that, my agent is going to be able to call all the tools of my MCP server. So let's running again. Running it. Yeah, FastMCP gives you a endpoint with /MCP, my bad. OK, so you can see here, you have some things happening on the bottom left. So it requires to list all the tools. And then you can see that it's calling the tool. So you have some call to request. You can see here that I'm still calling my roll dice. OK, first one didn't work. But it's calling 3 times my MCP server roll dice tool, and I have the results again. So now I was able to externalize my MCP server. And so my main agent doesn't do much, but it has access to tools through the MCP server, right? Isn't it cool? Thank you. All right, so that's basic. We have a function. It's an MCP. OK, it has a function as a tool. Tiffany mentioned another thing. We want to have an agent to manage our characters. So now what I want to do, I want to create another agent with who my game master agent can communicate to ask him to manage characters, OK? So let's do that. Let's create a new agent. OK, blank file. So you remember how you create an agent? Yes, we import agent class from Strands and create an agent. So here, I'm not going to be the one who called the agent manually. It's going to be my other agent who's going to call it. So I need to give it a bit of context of what it does. So I'm going to say, I'm going to give it a name. So it's like a management agent. I'm going to give it a description. Here we go. Oops, description. OK, description is like create and manage Dungeons & Dragons characters with a name, class, race, statistics, and background. And you can write and read character files. So in the final project we're going to show you after, Tiffany mentioned that we are using a database. Here, for the sake of the demo, because I don't have the whole afternoon, I'm not going to set up a database for the purpose. But what I'm going to use is I'm going to use the tools I have access to. And remember, we have access to file read and file write. So for the purpose of this demo, I'm going to use read and write on files as a database. But in a normal project, you're using a database to manage your characters, right? So I give it access to the tools. Here, I'm saying, OK, you have file read, file write. Here you go. And now I have my agent. Good? OK, so in order for this agent to be able to be called by my game master, I need to make it an agent server. So I'm going to create an A2A server here. And let me create a an object, which I'm going to give it the agent. So on this A2A server, agent-to-agent server, I want this agent to run. Again, I'm going to say, OK, I want you to run on my local host, and I want you to run on another port, like 8082, this one. It was 8081, the first one, right? Remember? Yes. Let's go with 8082. And then I'm going to say, OK, I want you to run. All right? So by just doing that, I created an agent which has access to tools. I have an agent-to-agent server. I'm just running it. So let's run it. OK, I'm running my agent character agent. So you can see it's running. So I have my MCP here, server, and my other agent running here. So I'm going back to my main game master, which, again, we don't want it to have any like capacity. It has to rely on other agents and tools to work. So I'm going to, import a A2A client to provider. So for the MCP servers, you need to create an MCP client for every MCP server you have, because you have to get access to their tools individually. So a bit of a difference, when you have access to an MCP server, you can list all the tools he has access to. Okay, and so you call a tool from this MCP server. When you call another agent, you just send it a prompt, and the other agent, which actually can use a different LLMs, you can use another model provider on this other agent, but these other agents, you don't know how he functions. You don't know what tools he has access to. You don't know if he's calling any other agents, because the purpose of it is to run his own LLM, to have his own like reflection and iterations, and then to give you an answer. So that's why for the MCP, we need an MCP client for every MCP server. For the agents, however, it's a bit different. I can say, OK, I create like an A2A client provider, and it takes an array of all the known URLs of all the agents you want to call. So here I have my agent, which runs on my 8082 port here. And if you have other agents, you basically it's an array, so you just put them all here, all right? We only have one now. And so what I'm going to do, I say, OK, this provider, he has tools. So now the tools here, it's not the tools of my agents. It's the tools of the provider that gives my agent access to calling other agents. Yeah, it's going to make clear in a second. It's going to be clear in a second. OK, so now I have my MCP client for my MCP server, my A2A client to provider to call my other agent. Let's give it a try. Create a D&D character name. Give me a name. Steve. Steve, who is a elf of the night. Yes, let's be.
Night elf. No way.
Night elf. Oh, so again. Roll the dice to generate its characteristics, then save it in a file. OK? So we're doing that. So now when you start to have a good practice when you have agents is that when you start to have like a lot of MCP or other like tools or agents you can communicate with, a good practice is to give it a system prompt. So a system prompt is basically a prompt that is going to tell him what to do, what it is responsible to. But something I like to do is to give it some guidances in this system prompt. So for example, here I said, OK, you're a D&D game master. You have access to different tools and agents. Use them when you need them. So like you can draw dice. You can create and manage characters. You don't need to tell him how to do it. Just like you have access to these things. Just use them if you want. And because we don't want it to do anything but only rely on these tools and agents, we just specify like never answer by yourself. Always use the tools and or agents. OK? It's a good practice. Let's do it. It's going to work, right? It's going to work. Yes, it's going to work. OK, let's go. So what is happening? OK, it's calling my MCP server, list to request. Also doing some agent stuff. So now it's running dices for ability score, some things. It's going to generate like 6 main abilities. So OK, strength 11, average Steve. 12 in dexterity, average Steve. 8 for constitution, not the best. Steve is quite intelligent, that's good. How many dice are we running? 6 in which, Steve is not the best character. And that's 10 for charisma. Okay, So now you have the characteristic, and you can see here, okay, so here, it's using this tool, A2A send message. And that's what I was talking about when I had the tools here. So the tools here are this kind of tool that allows my agent to call the other agents. So you can see at the bottom right that my other agents had been called. And again, he has access to like a file write tool, and he's asking me if I'm okay to use it. It's writing the tool, and now I have a file here, Steve Knight F character with all its characteristics. So you can ask him to write it as a JSON, whatever you want it. I didn't specify anything, so it's just like a file. The same thing, I can say, okay, what can you tell me about the character Steve? And if I execute that, again, okay, tools, we don't need the tools normally for this one. I'm going to say, okay, I need to check what agents are available to help me get information about characters. You can see that you say, okay, it's listing the agents. You say, I have access to a D&D character management. It's sending a message. And if I scroll up here, you should see that, tick, 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 tick. Here, it's using the file read tool. So it knows that he has a file about Steve. It's reading it, sending the response, and now we have my agent here, my game master, who receives all the information about Steve. And he even gives like some, like Steve likely relies on studying knowledge rather than blah, blah, blah. He gives his opinion. But basically, we can see that in a few lines of code, I have my first agent, another agents, tools. Something I didn't mention, though, I forgot to mention, when you have tools, so here it's pretty obvious. I have a tool that is, the function is called roll dice. It's pretty obvious. So when I ask my agent to roll a dice, it's going to check and say, okay, there's a function called roll dice. It makes sense that it's rolling dices. Now, when you don't have, if I generate the dog string, when you have multiple tools, you have to use dog strings. So that's how actually agent discover tools, using the dog string. Let me just clear that in. So you need to give it a description. You need to give it the arguments, and then you can return team and examples here. So when you have a lot of tools, it's actually using the dog string to use that. And that's what I use when I use the tools here, the current time. You know, the first time I said, okay, give me the time, and it gave me the time like UTC. But if you look at the code, the source code of the current time, you can see that he has a dog string here. And in the arguments, I can give it a time zone. So when I say in Las Vegas, my game master agent transcribed Las Vegas to the time zone and called the tool current time with the time zone arguments. You want to add something?
Yeah, just so that's interesting. When you write your tools, you're actually in the documentation of Strands. I don't know where it is.
Yeah, it was there.
Oh yeah. You have examples of good practices, and it's actually good to look at them. You have examples of good practices of how to write a good prompt. Because as Olivier said, this is crucial into your design because it uses this description to know exactly what the tool is doing. So there's a standard way of writing those dog strings now. And what I would recommend for you is not to write it on your own, but rather give the example to your AI code assistant, but make it generate by an AI and give them the example of the good practices that is in the Strands documentation, and then give them the function, and they will write a perfect doc strings for you. But yeah, I like almost never write my doc strings myself anymore.
Yeah, most of the time it generates it by default. So, but yeah, it's a recommendation to use the doc string because that's what you are. If you have like multiple tools, it may not know which one to call, so it's going to use the dog string to know how it's called, what it's doing, and what parameters it needs to take, and the type of the parameters. Good? Okay. Sure, I don't know how question works, but yeah, I'm open to questions. Yeah, so there's different ways agents can communicate and work together. Here what we did is like we just let the agent to discover the other agents and to call the one he wants. But if you go on the Strands documentation, there's different ways of creating agents. You can create like workflows. So basically you said like I have these agents and I want them to always be executed in that order. You can have like graphs of agents saying like, oh, these graphs are connected, these agents are connected. You can have like swarms of agents. Actually, if you go to, let's look at the agentic workflow here. I think you have a code sample. So here you have like an agent researcher, an agent analyst, an agent like writer agent. And so you can just tick, 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 tick. Where is the, somewhere here. All right. I don't know exactly, but there's the example somewhere. You have, how is it? But basically, you can do like workflow orchestrations, swarm, graphs. I think that's what you meant.
What's the benefit of using A2A over orchestration?
I mean, in the end, it's still going to use like A2A underneath. So the protocol is still the same that is used. It's the standard protocol. I don't know if that answered the question.
Is it like better performing? Is the A2A protocol better performing than the orchestrated agents?
The orchestration agent is still going to use like A2A, unless you run all the agents on one code, which you can do actually. You can run all the agents. The agent to agent, so what we did here, okay, I think I got the question, is that we run the agent on its own on a server, right, with its own like endpoints. But you can actually, you can do like they do here. It's like, okay, I have an agent here, and I have another agent that you write in the same file. And so in that sense, here it's not going to use A2A because they're all running on the same source code. I don't know if there's a good practice or whatever. The good thing when you have an agent running on its own server is that anyone can call it and it's not just for you. But that's the software design or architecture question. We have time. Are we good? All right. So that's it for the live coding demo, but we want to show you the final products. I mean, final products. Still a demo, but a bit better. Taking over?
Yeah.
All right. Should I run it?
Yeah. So it's really tiny at the screen. We realized this, but this is just to show you all of the different servers that we're running. So the first one that Olivier was running was the
MCP server here.
The MCP server is here. Then here is the character agent.
The rules agent.
The rules agent, and then
Master.
the orchestrator. And we have built a front end application.
Do you want to show the source code a bit before?
Yes, sure. So.
Tell me what to show.
So the MCP server is pretty much the same that we have shown during the demo. The character, here is the character
agent. Yeah.
Agent. So it has access to a database. We have not created a database together, but here it is. You can see that we have given the agent character a bunch of different tools to allow it access to writing into the database, reading the database, and also, I think, deleting things. So it really is managing this databases of characters.
And you can see like basically each tool here is literally just wrapping a database call. It's just like saying, oh, find character by name. We give it like a name. There's the dog string, and then the only important like line of code here is this one, DB search. It's just like wrapping, like an API would wrap database call. The tools are doing the same.
And all of that wrapped into a tool decorator.
Mm-hmm.
And we've made a massive system prompt and description.
Yeah.
Because you'll see as you iterate through your tests, prompt engineering is still a thing. You still need to make sure that your prompt is actually describes well the different actions that the agents can do. Specifically, if you want a certain format as an output, or specifically if you wanted to standardize, because for example, for creating a character, this is a pretty standard output for us. We always want kind of the same format and everything, so we needed to be very specific into what we wanted the character agent to perform. And also, This is the system prompt of the game master. So the orchestrator also has a massive system prompt. This is through several iterations of testing this demo that we've come up with this big system prompt. It's a pain that you have to go through, I guess. Like at the moment, testing how your workflow goes and iterating through different prompts is the way you can reach satisfactory outputs. Here
especially when you want like an exact output type.
Yeah, so we came up with this JSON format specifically because we had a front end at the end, and we wanted to be able to take each of the outputs and put it in the right place in your front. So, like at some point you're like, if you want to generate things automatically, you kind of need your orchestrator to answer to you in a standardized way. And this prompt actually works pretty well at the moment. Mm-hmm. I'm saying this, but maybe the demo's going to fail. But.
No, it's not.
So, live demo.
No way. Yeah, here we wanted like the response to be like used in web applications. We like give it a response based on this response, which is like what the game master is saying. Give us like action that you can suggest the user does after the player. Give some details, and if you roll some dice, just tell us the kind of dice you rolled, the result, and the reason why you had to roll the dice. Should we try?
Yes.
Okay. All right. So Steve, we still have Steve. Steve is a man, he is a dwarf this time, random, and he's a cleric. Okay, so I'm gonna take the URL of my game master. And let's go.
Okay, so as we launch the game, the AI Game Master has the instruction to launch a campaign and create the character, Steve, with the characteristics that we gave him. So what is Steve? It's a human?
No, he's a dwarf.
Dwarf
cleric, yeah.
So you see that there are different calls that have been made by the game orchestrator.
Some like the dice tool has been called, the character agent has been called, and it generates like an answer and send it back to the game. So let's see what we have here. You want to read what it says? Welcome to the room, Steve. Your English is better than mine.
Well, okay. Welcome to the realm, Steve. Your driver's boots crunch on frost-covered cobblestones as you approach the flickering torchlight. This is pretty cool. Like you can read the entire thing. I've played so many different games with this. This is pretty cool. So we have we asked the orchestrator to generate 3 different options that you can click if you don't want to type. So let's investigate.
Yes.
Investigating is cool because it usually leads to dice rolls, as you can see.
Okay, we have the response already.
So it was investigate the strange sound coming from the alley behind the tavern. And as the game master is rolling dices, we can get the results of the roll dices and put them in our front applications. Cool.
Or you can type what you want. If it's like run away, go home. I don't know. It's going to do the same. Do you want to try the rule thing?
Well, so this is where we know the boundaries of our demos.
Retreat.
Let's try to make it invoke the rule agent. Say something that has no sense. Like
fly to the moon, take your lightsaber, and kill the monsters.
So basically, if you want to do something that has no sense in the mechanics of the game, usually the game master will be like, hey, you can't do this. But we'll see if. So there's an error message first.
Yeah.
But.
Okay, let's ask him instead. Like, can I go to the moon? Can I fly to the moon? And back with my rocket. Let's see.
It should request the rule agent.
Aha.
Okay.
Something's happening here. Yeah.
So, yeah.
And the rules.
Oh, it's working.
Yeah. So
I'm so happy.
So for the rules agent, what we did, like we took the PDF of the game, we put it in a vector database, so it's like a RAG. And so that's how our agent is able to read it and say, like, Steve, you're still bleeding in the dark, alley-facing and dangerous bandit. There's no rocket in the medieval fantasy world of D&D. You are the first level dwarf cleric with
25
whatever.
feet of walking.
No travel, no sci-fi technology. Sorry.
Well, I mean, that's good because it's actually arguing as to why you can't do the things you want to do. But yeah, it's actually checked the rules of the games to see if you actually could not do this. So yeah, this is really cool. So as you can see in like a short amount of time, do we still have time?
Yeah, well.
Yeah, we're able to build multi-agentic workflow with the Strands SDK. Do you want to add anything else? Is anybody wants to try something? Or
Let me check, because you should be able to find these. Okay, just for those who want to see these in action, if you go on AWS samples, you have these sample once upon agentic AI. This is usually a workshop, but here, so by default, you won't see anything on this branch. But if you go on the solution V3 here, you have all the source code to run the demo we just ran. And if you go in the UI branch, you even have access to the UI that we use, which is like an Angular application. So feel free to go check.
let me share the QR codes
Yes.
with you. So if I go back to the presentation, so those were, if we failed, we had video
Backup
recorded
videos.
of the demo.
It worked. The demo
Yeah,
worked.
it did work. Yeah. Woo. Okay. So here are the code samples that you can get, also the Strands documentation, if ever you're interested. And if you have any questions, we still have a little bit of time. So thank you very much for your attention.